Hi students, this is day 2. Same thing we did yesterday. We're just practicing some more. We're going to use our trig identities to simplify trig expressions. So it's very important that you learn and memorize, if you're in pre-AP, the trig identities. When I first look at this one, I see a binomial because I see that minus sign, which says it has two terms. So my first thought is there a GCF I could factor out? Well, there is not, because the two terms don't have anything in common with each other that I could factor out. So my next thought is, let me rewrite everything in terms of sine and cosine, if possible. So like for instance, cosecant, I'm going to rewrite that. That is 1 over sine x minus, I like cosine x, so I'm not going to change it. We want everything in terms of sine or cosine, so we're going to leave cosine, times cotangent of x. I'm going to trade cotangent out for cosine x over sine x. Okay, I know that when I have two fractions that I'm multiplying together, I multiply my fractions straight across the top, straight across the bottom. That's why I put cosine x over 1. So I would make sure that they lined up, numerator times numerator, to give me cosine squared, and denominator times denominator, that will give me sine x. So we do have a common denominator. So we keep our common denominator, which is sine x, and we can subtract our numerators, 1 minus cosine squared x. If you know your identities, then you know that 1 minus cosine squared x is equal to sine squared x. So now we're down to sine squared x over sine x. Sine squared literally does mean sine x times sine x. So our sine x in our denominator cancels out one of our sine x's in our numerators, and we're left with sine x over 1. And sine x will be our answer. Okay, let's move on to example 2. Here's another binomial. I know it's a binomial because it's separated by a minus sign. Terms are separated by plus or minus signs. So my first thought is, could there be a GCF, something that both terms have in common? And they do. They both have sine x in common. So I'm going to factor sine x out, and I would have cosine squared x minus 1. Now, if you know your identities, which that's very important that you know your identities, you would know that sine squared x is equal to 1 minus cosine squared x. So this is very close, but not exactly the same. That says 1 minus cosine squared, and this one says cosine squared minus 1. So in other words, the sign is backwards. The signs are backwards. Up here we have a negative 1, down here we have a positive 1. Up here we have a positive cosine squared, down here we have a negative cosine squared. So what we need to do is factor out a negative, which changes the signs around. So now, after factoring out the negative, we do have 1 minus cosine squared. That is equal to sine squared, so we're going to trade that out for sine squared x. So we have negative sine x times sine squared. So we have negative sine cubed x. It's just like if you had x times x squared, that would give you an x cubed. Well, we have negative sine x times positive sine squared. That gives us negative sine cubed x. And that's as far as we can go with that one. Here's kind of the same thing. I look for a GCF. I have two terms, but there's nothing that they have in common. So my next thought is, let's rewrite everything using sine and cosine. So this is sine x plus cotangent x. I'm going to trade that out for cosine x over sine x. And by trading, what I really mean is substitute, times cosine x over 1. Cosine x over 1. Why did I make it over 1? Because when I have to multiply two fractions together, I want to make sure that they line up properly. So I want to make sure that I'm multiplying the numerator times the numerator and the denominator times the denominator. Okay, and we have sine x, and that's over 1. So remember, when we add or subtract fractions, we always want to have a common denominator. So we're going to have to get a common denominator by multiplying the first fraction by sine x over sine x, which is really, this is really multiplying by 1. So that doesn't change the value of the original fraction. That's going to give us sine squared x over sine x plus cosine squared x over sine x. Okay, now we're going to keep our common denominator. Now that we worked so hard to get our common denominator, we keep it and we add our numerators. So we have sine squared x plus cosine squared x, and that's going to be 1. If you know your identities, sine squared plus cosine squared is 1. So we have 1 over sine x. And if you know your identities, 1 over sine x, having sine in the bottom, is equal to having cosecant in the top of a fraction. So we end up with cosecant x. And the last example, example 4, we've got cosine theta over secant minus tangent. This one's a little tricky. You have to have seen these work before probably you would think to do this. We're going to multiply by the conjugate of our denominator. Remember, conjugate just means we're changing the sign in the middle. So we're going to multiply by secant theta plus tangent theta over secant theta plus tangent theta. So what I've written in pink is really just 1. So we're just really multiplying by 1. So here we go. Let's distribute cosine. Cosine times secant. Cosine and secants are reciprocals. Anytime you multiply reciprocals together, you will always get 1. Then cosine times tangent. So that's cosine x theta over 1 times tangent. Tangent is sine theta over cosine theta. My cosines are going to cancel each other out. Because you're multiplying, we can cancel. So that really will give me 1 plus sine in my numerator, but we'll come back. We talked about when we multiply conjugates together, you really only need to take the first times the first. So secant times secant is secant squared theta, and the last times the last, a negative tangent times a positive tangent is negative tangent squared theta. So now we've got 1 plus sine in the numerator, 1 plus sine theta in the numerator. Let me just do that over. 1 plus sine theta in the numerator over secant squared minus tangent squared. If you look back at your identities, secant squared minus tangent squared is 1. So 1 plus sine theta over 1 is 1 plus sine theta. And that will do that. Thank you, and you guys have a great day. Bye. And there's a worksheet labeled Day 2 worksheet.